Hey students, Ms. Pratt here. This is a follow-up video to the Law of Signs introduction, and in this video we're going to be talking about how law of signs can have what's called the ambiguous case. So the first thing that it's important to know, let's break down our words here a little bit. This term ambiguous is derived from the Latin term ambi and greer, and this is talking about multiple ways of doing something. So our current running definition of ambiguous is something that is unclear or open to more than one interpretation, meaning it has more than one meaning. And this can be true for triangles. Sometimes a set of given information can create more than one triangle. So you might have some measurements that can create one triangle, two triangles, or no triangles at all. And so we're going to talk about these different cases and why they show up. But before we get into triangles, I just want to talk really quickly about the idea of multiple solutions to something. So we've seen this before, and probably where the most common is when you have an equation, something like this. Let's say you have the equation x squared is equal to 36. And if you were to solve this equation, you would do this by taking the square root of both sides. So the square root of x squared would give you x, and the calculator would return 6 as the square root of 36. And this is true because if I were to check my work, I could take 6 squared and I would get 6 times 6, which is 36. So that is a true answer. But if you remember back to when you were solving quadratic equations, whenever you take the square root to solve a quadratic, you also need to know that there's a second solution to this equation. Not only can x be 6, but it can also be negative 6. This is true because if I take negative 6 and I square it, it's going to give me 36. So even though there are two solutions to this equation, the calculator is only going to ever return what is called the primary answer. And because of that, sign works very similarly. Whenever you're solving an equation, sign will only ever return what is called the primary solution, especially the inverse of sign. But there can be more than one answer to the problem. So let's take a look at a basic problem. Let's say we have the sine of some angle that we don't know. We'll call that x. And we're going to say the sine of this angle x is equal to 1/2. If I want to solve this equation, the first thing I do is I recognize that that x is inside of the trig function sine. And in order to be able to solve for x, I'm going to need to use sine's inverse. So x is going to be equal to the sine inverse of 1/2. I'm going to use my calculator to find this value. And make sure your calculator is in degree mode. So the calculator is going to return a 30-degree angle. We can check our work. We can find the sine of 30 degrees. And we should find our calculator will return 0.5, which is 1/2, so this works. But here's what the calculator won't do. The calculator will not find sine's alternate angle that would also give you 1/2. To find sine's alternate angle, we always want to find the angle that is supplementary to the angle that we found. Supplementary means that this angle and the alternate angle will add up to 180. So whenever you have given the first angle from your calculator, you're going to take 180 degrees and subtract the angle that the calculator found. This will find the alternate angle that will work for this equation. Let's check our work. We're going to find sine of 150 degrees in our calculator, and we want to also make sure that it equals 1/2. And it does. When I type sine of 150 degrees into our calculator, I also get 0.5, and so this is also going to be a solution. So again, whenever we're solving a sine, and this is going to be true again for any time we're taking the sine inverse, we're going to have two solutions. We're going to have the one that the calculator gives us, which is going to be an acute angle, and we're going to then find a second angle, which is an obtuse angle. And the reason why we've never had to worry about this before is we've only ever been dealing with right triangles. Well, you can't have an obtuse angle in a right triangle, so that's never been an issue. But now that we're going to be talking about other types of triangles, we want to look at this other angle, this obtuse angle, and see if it can also create a triangle. The ambiguous case is going to occur when you have two sides and an acute angle. Anytime you have two sides and an acute angle given, we want to make sure that there are three possible options. There are either going to be two completely different triangles that we can create, one triangle, or zero triangles. And we want to make sure that we check all cases. So we're going to check each triangle that could be created. The process of doing that is described below. I would write this down, and this kind of gives you a step-by-step instructional guide of how to approach these law of sines. So first, we're going to check law of sines. If law of sines fails, then that means the information that we have is not sufficient to draw a triangle. Maybe one side is too short and it will never connect to the base of a triangle based off of an angle. So we've been given not enough information to actually create a triangle. If law of sines works, then we're going to find a right or an acute triangle. Again, law of sines, whenever you're solving for an angle, the calculator is only ever going to return an acute angle or a 90-degree angle. If that works, you can solve that entire triangle. If law of sines works and the acute triangle is found, you want to check for the obtuse triangle, and you want to check all angles of the obtuse. So we're going to, and essentially what's happening here is you are finding not just one triangle that is an acute triangle, but an obtuse triangle as well. And we'll talk about how that works. For our first example, they have given us three pieces of information. They've given us side A, side C, and angle C. And they're asking us to solve the triangle, which means they want us to find all remaining parts. Okay, so the first thing I'm going to notice is I'm not even going to draw a triangle here, but I am going to notice that I have two sides, side A, side C, and I have angle C, which creates a pair. Because I have a pair, I can use law of sines to find the angle that will go with the side that I currently have. So the first thing I'm going to do is I'm going to use law of sines to find angle A. So I'm going to set up that proportion by creating the side 6 over sine of the angle that is across from it, so 15 degrees, and setting that equal to side A, in this case 10, over sine of the angle A. I'm going to use cross multiplication to solve this. So I'm going to multiply 6 times sine of angle A is equal to 10 times sine of angle 15. I'm going to divide both sides by 6. So sine of A is equal to 10 times sine of 15 over 6. Okay, now here I am where I have the sine of an angle is equal to some numerical value, which is 10 times the sine of 15 over 6, and I need to solve for A. To solve for A, I'm going to use a sine inverse. Again, you can't divide by sin. You have to use the sine inverse of this entire expression of 15 degrees over 6. And I'm going to type this into my calculator. And the measurement that I get is 25 point, it's 5/5, but I'll round to a 1/10 of a degree, so 0.6 degrees. So this is one option for angle A. Well, what we also have learned is that A could also have been an obtuse angle. So I'm going to call this A prime, which is a different option for A. And again, to find that, I'm going to take and find the supplementary angle. So I'm going to do 180 degrees minus my 25.6 degrees. And I get 154.4 degrees. So now A has two options. A could be this 25.6 degree angle, or it could be this 154.4 degree angle. So I actually have two cases here. I have case 1, and then I have case 2, which I'm going to do in a separate color. Okay, so again, just to recap, the first thing I did was I found angle A because I could use law of sines to find that missing part. And then when I found that missing part, I noticed that I got an acute angle. So I subtracted from 180 to get the obtuse form of this signed angle value. Okay, so now I have 2 cases, and so what I'm going to do is I'm going to break this problem down into my 2 cases. Okay, so case number 1 is that I have all my existing features, and angle A is equal to 25.6 degrees. Okay, well, if that's true, we do know that angle C is still 15 degrees, so that's going to be helpful to find angle B. Keep in mind, we know that all angles in a triangle have to add up to 180 degrees, so I can find angle B by taking 180 and subtracting my measurement for angle C, which is 15 degrees, and this angle A, which is 25.6 degrees. And I get 139.4 degrees. Okay, so just checking back in my process, I had side A, I had side C, I have angle A, angle B, and angle C. So the only thing left to find is side B. And I'm going to use another law of sines to find that. Now we've had some practice with law of sines, so I'm going to do all this work off camera and see if you can set up a ratio to find side B. Okay, I found my side B to be 15.1, and that's not an angle, so I don't need a degree symbol. I almost added it. But this is a side length, and so this is one full triangle that I can find by using law of sines and these 3 original measurements. But I don't want to forget this other option for angle A. Angle A could have also been 154.4 degrees. If that's true, then angle, and again, we'll call that A prime because this is an alternate answer for A. Well, if I have an alternate angle A, then I'm going to have an alternate angle B. And I can find that by, again, understanding that all my angles in a triangle have to add up to 180. So I'm going to do 180 minus my angle A, 154.4 degrees, and again, the given C. I can't change the given information, so that is still going to be part of the problem. And I get that angle B could also, if angle A was 154.4 degrees, then that means angle B could have been 10.6 degrees. So I'm creating this second triangle here. So this has nothing, it has all the original given information, but it has none of the new values that I solved in the first triangle for A, B, and side B. So I have a new A, I have a new B, and I'm also going to have a new side B that is going to be based off of this information of this triangle. So again, I'm going to set up another law of sines to find that side B. And I guess I should technically call this side B prime because this is a different answer for B, side B. And so we're going to keep our original pairing, set it equal to B prime over 100 sine of 10.6 degrees and solve for this side B. And I got 4.3. So again, what I'm doing here is I'm creating 2 totally separate triangles. The first triangle is all the original given information and these 3 measurements. And the second triangle that I'm creating is all of the original information and these 3 new measurements. I'm going to draw these 2 triangles so that you can see what they look like and how this kind of shows up. Again, it's the ambiguous case because our original set of information, this A value of 10, this C value of 6 and this angle C of 15 could actually exist in two separate triangles, meaning which triangle they're talking about is ambiguous because the triangle that can be formed, there's more than one answer. Okay, here are those two different triangles. Both of these triangles have C values of 15 and 15. They have a length of 10, or approximately is the best I could do, an A length of 10, and a C length of 6, or as close as I could get it to 6. And again, we can see these measurements existing in two separate triangles. So again, the original piece of information that we were given could create two separate triangles. Again, the way you approach these types of problems is you set up an original law of sines. When you solve for the angle, you find not only an angle, but an alternate form of that angle, which is the supplementary angle to the one you found. In other words, you subtract from 180 degrees to find the angle's alternate option. And then you kind of split this into doing the same thing twice. Now that you have two separate A's, you find two separate angle B's, and then you find two separate side B's depending on the information that you have just found. Okay, here's a new problem, and we're going to start this problem like we started the last problem. We have a side A, we have a side B, and we have an angle B. So I'm going to set up a law of sines using a pairing of B over sine of B, angle B, and setting that equal to A over sine of A. So again, we're still going to be finding this A first. Here's my proportion, and I'm going to cross multiply and solve. And I found first A to be 20 degrees. This is the angle that the calculator gave me upon typing the sine inverse into my calculator. And now I'm going to find the other option for A by taking 180 and subtracting that 20 degrees of the A that we found in our calculator. This would give me an angle of 160 degrees. So now I have these two options for A, so I'm going to split my work into two separate options. My first option is all the original given information plus angle A we now know is 20 degrees. I have angle B, so I can find angle C by doing 180 degrees minus angle A and angle B. And I find that angle B is 125 degrees. Okay, I'm going to finish solving this triangle because I have angle A, I have angle C, I have angle B, and I have two of my sides. So I'm going to use a law of sines to find side C, and I found C to be 7.1. I want to focus on the other triangle that I could create as well, where we have all of our still original pieces of information, but now A has this alternate angle of 160 degrees. If I try to find this third angle C, well, we know that all triangles have to fit into 180 degrees. So angle C is, or angle A is already taking up 160 of those degrees, and angle B is 35 degrees, which means my angle C would have to be negative 15 degrees in order for this triangle to work. Well, you can't have negative angles inside of a triangle. So what's actually happening here is even though A has a different option, right? We have two options for this angle measurement. It could have been 20 degrees. It could have been 160 degrees that would work for this proportion. Not both of these angles create triangles. Only the 20 degrees is going to be able to create a triangle. This 160 degree angle is too large of an angle to be in a triangle where we have a 35 degree angle. So even though this angle exists in sine, it doesn't actually create a triangle. So here's a case where we did law of sines. There is an ambiguous answer for a sine inverse, but only one triangle can be created. So our final answer here is when it says solve the triangle. Well, we're only going to have one triangle that can be solved, and this would be my final answer, where I would show that a second angle could not be formed. So here only one triangle can be formed, and we found all the appropriate pieces for that triangle. Okay, last case, and I promise it's a quick one. See if you can set up a law of sines to find the first piece of information you could find in this problem. Okay, here's my proportion that would solve for angle B. I'm going to solve this by cross multiplying. 5 times sine of B is equal to 8 times sine of 50 degrees. Divide both sides by 5, so I have sine of B is equal to 8 times sine of 50 degrees over 5, and then I'm going to find the sine inverse. So B is equal to the sine inverse of 8 sine of 50 degrees over 5. And I'm going to use my calculator to type this in. When I do this, my calculator is going to return an error. So what's happening here is we have given some pieces of information, and there does not exist an angle that can live in this triangle. If I tried to draw a picture of this happening, here I have an angle of 50 degrees. I have one of the sides coming off of that 50 degrees, side B, as 8. And then I have the side across from this set to angle, to be a length of 5. And you can see that this side is just too short. There's no way that if this angle is 50 degrees that there's any way that I could take this side and have it connect to form a triangle. So anytime you get an error in solving your law of sines, what is happening is this information can't form a triangle. And so the answer that we say is 0 triangles can be made. So 0 triangles formed. Okay, that's it for the ambiguous case of law of sines.